Good afternoon and welcome back. So today what I want to look at is I want to look at chapter 36. This is more or less about refraction, and remember, refraction is the bending of light. And why does it bend? It bends because there's a change in speed or a change in velocity, depends how upmarket you want to be. I'm going to do questions 9 to questions 12, and this is on page 442, 443. Again, what I want you to do, I want you to watch this video, God help you. I then want you to do the questions to the highest standard that you can do. I then want them uploaded on Google Classroom, and I will mark them, and they have to be done within the time. So you know what to do. So let's get it done. So I'm going to start with question 9, page 442. It says figure 36.13 shows a ray of light passing from air into the cornea of the eye. So the air, you have a look at the diagram, you can see the air, you can see the cornea, you can see the normal is a dotted line in this case. I don't usually draw this a dotted line, but I suppose it's best, but then I usually draw the screen line. You can't really dot this that much. So let's see, can I draw this to see what way the cookie crumbles? So you can get a few answers. So I'm going to draw the interface, inter meaning between. I thought it was. Let's go again. There we are. And now I'm going to draw a normal. Remember, a normal is a line at right angles. I'll see, can I dot it? Not getting much success on that. There's it now. Right, there's the dotted line. The pen doesn't like a ruler. Right? So there's your dotted line. So we'll do the ray of light being red. So the ray of light comes in. So let's see, can I draw that? 34 degrees. There's it coming in. And there's the angle from the normal. And it is refracted, bent, because the velocity changes. So that's the reason it bends. And I suppose we better label, and that's the air, and that's the cornea. So that's that done. And remember, you're going from less dense to more dense, so it's going to bend towards the normal, which it does. Less to more dense, towards. Now, I'm going to make up a new one. Fast to slow, towards. Fair enough? Fast to slow. So it's fast here, it's slow here, and it bends towards now. So there's a new one you can put in your mnemonic. So let's answer the questions. State the angle of incidence. Watch the blue box. There's there, 34 degrees is your angle of incidence. First one done. State the angle of incidence and the angle of refraction. Angle of refraction is 24. Fair enough. In which of the two media does light travel the fastest? So light travels fastest in air. Travels fastest in air. Now, do part B. What is the evidence for believing that red light travels faster in glass than blue light? Well, this is your spectrum formed in a prism. The dear old Isaac Newton was the first man to show it, but he wasn't really, because leprechauns showed it whenever they had the rainbow. So Isaac was really wrong. So, and we know that violet deviates the most. So if violet deviates the most, it must slow down the most. So let's get the answer. Red light bends less than blue light when, I'm off the page there, am I? When refracted. Yes, that wasn't too good. In glass, according to me, I'm not of it. Red light is faster than blue light. in glass. Fair enough. I better go up here. I just want to check that. You see that there? See that? Follow the blue dot. That's not supposed to be. I'll put this over here. LTM. Less dense, more dense towards. And then I'm going to put the new one. FTS. Fast to slow towards. It's hard to keep your eye on two things. Fair enough. There's a new mnemonic for you to learn. Right? So that's that question done. That's question 9 done. Now question 10. And question 10 is one slippy question. It says a beam of sound is made underwater. A beam sound. You read it. I'm reading it. A beam sound. Right. A beam sound made underwater travels towards the surface. Sound travels faster in water than it does in air, and this is because the particles in the water are closer together, so the energy passes on quicker. Copy and complete figure 36.14 to mark the refraction that occurs when the sound travels into the air. Mark the normal in your diagram. Right, better draw the diagram. This could be a true story about fungi, but maybe it's too soon to mention fungi. Right, so there's, wasn't as coarse as that one, right? Right, I'm going to do the normal. Again, you should do it a dotted line. I'm going to try it green again. Yeah, and there's my normal. And I will do the beam of sound, or sound beam. There's it coming up. See that? It shows the arrow. Now, I want to make sure I can get this in now, because to me this is important. FTS, fast to slow towards. That's that new mnemonic. And then SAF. What do you think that stands for? Slow. Fast. Away. Fair enough. So that's that one. So we are going from fast, follow the blue, fast to slow. It should go straight on through, but it bends. I'm in the right colour. Now. It bends towards the normal, like so. Fair enough. So that's that one done. That was a slippy question now. Right? Sound is different in media than light. So now I'm going to question 11. Question 11. Question 11. So what have we got? It says different shapes of glass prism are often used to change the direction of light rays. It's called spectacles, called your eye lens, called your cornea. Fair enough. So here we have a strange shaped prism. So I'm going to draw this. Again, your diagram has to be accurate. And I keep saying these light questions are about accuracy more than anything else. So there's, oh lovely. Right, so our dear old ray of light comes in. Here it comes. There's it coming in. Now, that will not be refracted. It will slow down as it comes into the, there's the air, there's the glass, there's the air again. Yes, it will slow down as it comes into the glass here. But it doesn't refract because it's at right angles to the face, or it's no angles to the normal. So it'll just pass straight through. Fair enough? Now it's a different story. We're going to draw on normal. Again, your normal at right angles. Remember, I'll be checking this. There's the normal. It's at right angles. I have measured that carefully with a protractor. And I'm going from, now look, let's go back. Here we're going, I wonder I'm still on the page. Yeah, more dense, which is glass, to less dense. It bends away from the normal. You could also look, you'd also put a look, slow to fast. slow. The fast, away from the normal, right? Back to red. It should pass straight on through, but it doesn't. It bends away from the normal. Whee! And let's label it with the arrows. Happy days. So that there's wee tricky by that. There's no refraction there. It does slow down. There is refraction here. Slow. Fast. Away from the normal. Yes. So that's that one done. And now let's do question number 12. Now, these questions are poundy kicks, like. You're getting the data off the table. But people still don't take their time. So I'm going to write down one word before I start here. Time. The answer's on the page. So let's answer the question. Between which pair of materials does light show the greatest change in speed? I'll have a look at them. 3 by 10 to the 8, 2.3. They're all by 10 to the power of 8. So the biggest change between air and diamond. Fair enough. Between which pair of materials does light refract the most? Well, again, it's the same. Between, because that's the biggest change, so that's going to be the biggest refraction. Between air and diamond. Biggest change. Biggest refraction. So there you are. Does light bend towards or away from the normal when it passes from water into diamond? So let's have a look. Water into diamond. So it's going to travel, right? Whereas you put your finger on the water, there's water's 2.2 and diamond's 1.2. So it's from let's see, water, just write it down there. Water is, hold on, from water, 2.2 by 10 to the power of 8. And the diamond is 1.2 by 10 to the power of 8. Where to get those data? Off the table. So it's going from fast to slow, fast to slow, fast to slow. So it bends towards the normal. Fast to slow. It's towards the normal. So the light slows down. See the way I'm working these things out? I'm not just guessing. Light slows down, bends towards the normal. Grand. Fair enough. So there's questions 9, 10, 11 and 12 done. 10 was a slippy by. But then don't be at all surprised. And there's a new mnemonic for you to learn. SAF and FTS. So what do you do now? You went over this. Now go back, do the questions on an A4 page to the high standard that I want. Upload it into Google Classroom before the deadline. And I'll mark it and I'll send it back to you. Thank you very much. Talk to you shortly.